Okay, here we go. Lesson 4.3, homework. All right. Good news, bad news. Well, the good news is this is just another application of proving that two triangles are congruent. The bad news is these are going to be proofs, and these are going to be a bit challenging until you wrap your head around what's going on. Now, once you do and you kind of see the pattern, there's going to be two basic patterns today, then it ends up being not too bad. All right. So our two objectives of the day. And I would state that until you get the hang of things, until you see what's going on, these are a little challenging. But I'll try to walk you through each one slowly. All right, the big picture. What are we doing here? We're going to have two big ideas today. First big idea is this: you're going to be asked to show that two segments are congruent. Hey, there's two segments right there, ACDF. Show that they're congruent, right? Um, Except those two segments are going to be part of two different triangles. Those segments won't just be sitting there by themselves, they will be on two separate triangles. So, how do we show that those two triangles are congruent, right? Or, this isn't the second flavor, this is still the first flavor, or show that two angles are congruent. So, in other words, show that angle C is congruent to angle D. Once again, they're going to be part of two different triangles. So how do you do this? Either show that two segments or two angles are congruent. Well, we're going to use our silver bullets, right? First thing we're going to do is we're going to show that the two triangles are congruent, either by SSS, SAS, or ASA. We'll still get the two extra bullets, but not today. It's not like in two lessons. So step number one, show that the two triangles are congruent. Step number two, once that's done, is simply use the magic words CPCTC. Now, why does that work? Well, let's think about what CPCTC means. CPCTC means the corresponding parts of congruent triangles are congruent. So therefore, if you want to show that the two segments or the two angles are congruent, and they're part of two congruent triangles, then all the corresponding parts are congruent. So the two parts that we're trying to show are congruent are part of congruent triangles, and they're corresponding, therefore they must be congruent. Now that makes perfect sense once you understand this, but if you don't understand it, that's a mouthful, right? So maybe to help your understanding, right, is we need to do some examples. So some students will get that immediately. Other students will be like, this little girl, what? I don't get it, right? One more time. What you're going to do to show that two segments or two angles are congruent, you're going to show that they are part of two different triangles and the two triangles are congruent, and then claim CPCTC. And CPCTC is a magic word, which means the corresponding parts of congruent triangles are congruent. All right. All right, so this is flavor number one to show that two parts or two segments or two segments or two angles are congruent. And we'll do a couple of examples. All right. So I'm supposed to prove that angle A is congruent to angle C. This will be a talking proof, not a two-column proof. All right. Prove that angle A is congruent to angle C. Well, I immediately see a problem. And the problem is there aren't two triangles, right? How are we going to fix this? Well, hopefully you're screaming at the screen right now and you're like, well, let's just make two triangles. If I make the two triangles like that, look what I just did to angle A and angle C. Maybe I cut them in half, I don't know, but I certainly broke them up into two pieces, so that might not be what we want to do. Instead, maybe we want to draw the line between D and B. If I draw the auxiliary line between D and B, now A and C are sitting there by themselves, and it should work. Okay, so that's what we're going to do. I've now made two triangles, triangle ABC and triangle CDB or CBD. No, it's CDB. And I'm now going to show that those two triangles are congruent. Okay. I'm going to show them congruent by one of our three silver bullets. Eventually, we'll have five. Let's see. How can I do that? How can I do that? Well, I noticed that those two sides are both equal to 4. So that means they're equal. Oh, and look, I've got a side of 9 and a side of 9. And then lastly, hopefully you're yelling at the screen, look at the middle. They share a common side. So the reflexive property would say that DB is equal to DB. Therefore, the two triangles are congruent by SSS. So by SSS, the two triangles are congruent. And if you were paying attention, I said then we say the magic words, and the magic words are CPCTC. Now, why does that work? We were trying to show that angle A is congruent to angle C, and look, Look at our triangle congruency statement. Angle A is the first letter and angle C is the first letter. So therefore, they're congruent because of CPCTC. The corresponding parts, A corresponds to C, B corresponds to D, D corresponds to B. So the corresponding parts are congruent by CPCTC, and we're done. That almost seemed too easy, but I understand the first couple times you do this, it's a little bit more challenging. So what am I going to do? Once again, I'm going to show the two parts apart of two different triangles, show the two triangles congruent by our 5 silver bullets, and then claim CPCTC. All right. We're going to do two examples. Two examples. Here we go. Now, these are going to be actual two-column proofs. All right, so we set up our two-column proof, and that's where we're going. And immediately you should see that, hey, we're trying to show that the two parts are congruent, Q and S, right? And they're part of two different triangles. Sorry, I already know how this proof is going to end. This proof is going to end with CPCTC, right? The question is, how do I get there? I get there by showing that the two triangles are congruent. Which two triangles? Triangle on the top, PQR, the triangle on the bottom, PSR. Well, how do I prove that, right? Maybe you're yelling at the screen right now. You can see this, but if not, I'm going to go to the given and simply read what it says. Well, it says that PR, that's the middle part right here, bisects this angle right here. So if it bisects that angle right there, the consequence of bisecting, when you bisect something, you cut it in half. Well, that makes two congruent angles. And so the two, I'm sorry, I did this out of order. The other part of the given, we'll get back to bisecting here in a second. The other part of the given is that PQ is congruent to PS. So I'll just mark that with tick marks. So PQ and PS. All right, now I'll get to the bisecting. Um, well, the consequence of bisecting, you make two congruent angles, PQR and SPR. That's just the definition of bisecting, right? If you bisect an angle, you cut it in half, you make two equal parts. Two equal parts. Okay. So let's mark that. And then lastly, probably what you are yelling at the screen at is that, ooh, reflexive property. See the middle? That's part of the top and the bottom triangle. So we got the middle part, reflexive property. And now let's read the triangles. Read the top triangles. It says SAS, two sides in the included angle. Look, read the bottom triangle. It's SAS, two sides in the included angle. Therefore, the two triangles are congruent. Now, how do I name them? That's the more important thing when I name them. It doesn't matter how you start, but if I start with Q, and if I go in this direction, I'm going down the one tick mark side to the congruent angle and then back to the two tick mark side. So we would need to do the same thing. So that would mean start with S, down the one to the angle to the two tick marks. Now, that's just one of many different ways of naming the angle or naming the triangle. And okay, so there we go. PQR is congruent, or triangle PQR is congruent to triangle SPR. And now if we look at the corresponding parts, the first letter Q is congruent to the first part S. And that was what we were trying to prove. That CPCTC is magic words. Okay. So that's how you prove that two angles are congruent. How about two sides, right? Big picture, once again, we're going to show the two parts part of two different triangles. Claim the two triangles congruent by SSS, SAS, or ASA. Two more to come. That's usually the hardest part, this middle step. And then lastly, claim the magic words CPCTC. So let's look at one where we're trying to prove sides are congruent. If this looks like the same triangle, it's because it is, just the given is different. All right, so let's see. What's the given? This time it says that that middle part, PR, bisects two angles this time. I still know how this is going to end. It's going to end with the magic word CPCTC. All right. But let's see. What's the consequence of the middle part? Oh, the middle part, which is this part right here, and it says it bisects this angle and it bisects this angle. So if that's the case, it bisects both angles. The consequence is it makes two congruent angles. So for QPS, I get QPR and SPR. And then for QRS, I get QRP and SRP. That makes sense, right? Okay, let's put some tick marks and some arcs. So those two angles are congruent. Now these other two angles are not the same angles. That's why I'm putting two arcs, right? And then yes, hopefully you see it. Look at the middle. We got a reflexive property still. So now let's read the top triangle. It's an ASA. It's two angles on the included side. And let me read the bottom one. It's also ASA. So therefore, if I go from Q, follow this order. If I start from Q, I'm going down to one arc, past one tick mark to two arcs. So that's the pattern. Go down to one arc, past one tick mark to two arcs. So that's QPR and SPR. And if you notice, right, that's also the same statement as the two angle bisectors. All right, so that's ASA. Magic Works, CPCTC, and we're done. So that's flavor number one. Show that two angles or two sides are congruent. The steps are show that they're part of two different triangles, show that the two triangles are congruent, then claim CPCTC. So there you go. That's half of the homework right there. All the proofs are going to follow this pattern. The only thing that's going to change is this middle part right here, right? This middle part right here is the part you got to do the work on. How the proof ends, it ends the same way. It always ends with CPCTC, and the step before that is you show that two triangles are congruent. The only thing that changes are the reason why the two triangles are congruent and how you got there. How did you get that the two triangles are congruent? But this is the basic pattern of all the proofs tonight for homework where you're asked to prove that two sides or two angles are congruent. All right. I would highly encourage you, if that didn't make sense, to go back and play example two and example three again and notice the commonality, notice the pattern, notice the similarities. Okay. So once again, to beat a dead horse, right? What are you going to do for these flavors or this flavor? You're going to show the two parts are part of two different triangles, show the two triangles are congruent, and then claim CPCTC. All right, that's half the homework. Second, and the last biggest idea, it's going to seem similar, but it's not exactly the same. Here it is. You will be asked to show that two segments, not two angles, this is just going to be segments, that two segments are parallel instead of being congruent. They might be congruent, they may not be, but you're going to be asked to show that they're parallel. Okay, so this is also going to have a similar pattern, right? And the pattern is that these two parts are going to be part of two different triangles. These parts are going to be part of two different triangles, right? And what are you going to do? Here's what you're going to do. You're going to show that those two parallel or soon to be parallel parts are part of two different triangles. Sounds the same as the previous one. Then you're going to show that two triangles are congruent. Hey, that's the same step. It's the next two steps that are different. Yes, you're going to claim CPCTC, but you're going to claim it for two specific, not sides, but angles. This will make sense when we do the problem. You're going to show that it's true for two angles that are actually alternate interior angles of two lines cut by a transversal. And since we know that if two lines are cut by a transversal and alternate interior angles are congruent, that's what makes them parallel, then that's how the proof is going to end. So this proof is just slightly more challenging. It adds one extra step. Show that the parts are part of two different triangles. They won't be angles this time, will only be sides. Show that the two triangles are congruent, that's the same. But now you're going to claim CPCTC for two specific angles, and I'll show you those two angles. And then those angles are going to be alternate interior angles, and therefore, if you have alternate interior angles are congruent, then the two sides that are cut by the transversal are parallel. All right. Once again, maybe that didn't make sense, but hopefully it will after example. All right, so we're going to do those steps right there. One, two, three, four. All right, here's your example. I'm going to show that, let's see, or sorry, AD is this side right here is parallel to this side right here, CB. That's what I'm trying to show. If you notice, I'll draw them right here. Those two sides are exactly the same as two sides cut by a transversal or two parallel lines cut by transversal. The only difference is we don't know they're parallel yet. So the basic idea is if somehow we could show that this piece right here and this piece right here are congruent, those would be alternate interior angles, right? Then therefore the two sides are parallel. And if we look back to our original picture, what are those two dots? Those two dots are angle A and angle B. So if I could somehow show that angle A and angle B are congruent, then they're alternate interior angles for sides AD and CB. I would highly encourage you to play that little part a couple times for it to sink in. All right, so here we go. How are we going to do this? Well, we know that we're going to claim that alternate interior angles are congruent and the lines are parallel. We know that's how it's going to end. So this one doesn't end with CPCTC. But the previous step, either A and B or D and C, either one would work, right? I'll draw that one as well, right? Here's AD, here's CB, here's it being cut by DC. So if I could somehow show that this angle and this angle are congruent, those are alternate interior angles, and those are angles D and angles C. It also would work with A and B. I thought I chose A and B, but I was wrong. And the proof is exactly the same, regardless of which two you change. All right, so let's see what we can do. So once again, I can actually put CPCTC there because I know that's going to be true. So I simply need to show that the two triangles are congruent. All right, so how am I going to do that? Well, you can either look at the picture first or you can look at the given. It doesn't really matter which one. So if I look at the given says that A, B, and CD bisect each other. That means they cut each other in half. That means that this part must be congruent to this part, and this part must be congruent to this part, right? That's a consequence of being a bisector. You make equal parts. So that was my statement, right? Definition of the bisector, and there are my neater tick marks. You guys see anything else? Hopefully you're yelling at the screen, hey, look, I got an X. When you get an X, you have vertical angles. So pick the two angles of the triangles. That would be AMD and BMC. Right? Those are congruent because they are vertical angles, arc, arc. Now read the two triangles. Look, SAS on the left, SAS on the right. So let's see, triangle AMD is now congruent to triangle BMC because of SAS, and that's the whole darn proof. Once again, the power of this is that fact that if they are parallel, then if angle D and angle C are congruent, well, they are part of, if I draw it this way, you can see it a bit clearer. They are part, this is angle D right here, and this is angle C, then there are alternate interior angles. And if the alternate interior angles are congruent, that only happens when the two sides that are cut by the transversal are parallel. All right, so that's how that proof works, right? Once again, for this one, it has an extra step. It still show the two parts are part of two different triangles, show the two triangles are congruent. Now we just don't say the magic word CPCTC. We say CPCTC for two specific angles, and those angles will be the ones that are alternate interior angles. And the last step, if the alternate interior angles are congruent, that only happens when the two sides are parallel. All right, we'll do one more. All right, we're supposed to show that WX is parallel to ZY. So let's see, where's WX? WX is the bottom and ZY is the top. And if I could somehow prove that angle 1 and angle 2 are congruent, if I draw it this way, it makes more sense. If I could somehow show that angle 1 and angle 2 are congruent, that would be this one and this one, right? Then therefore those are alternate interior angles and they're only congruent when this side is parallel to this side. So that's the big picture of what I'm trying to accomplish. Okay, so let's do the proof. I know how it's going to end. It's going to end with if alternate interior angles are congruent, then the sides are parallel. Therefore, I simply need to show that angle 2 and angle 1 are congruent by CPCTC. All right, let's see how we can do this. All right, what's the given? What's the given? What's the given? The given is WX is congruent to ZY and ZW is congruent to XY. So let's make tick marks there. So WX is the bottom, and that's congruent to the top, and ZW is the left side, and that's congruent to the right side. Are you yelling at the screen? I hope you are, because look, we got a reflexive property. Therefore, the two triangles are congruent because of SSS. All right. And that's the whole proof. We're done. I like this one because we did like two complete steps from the bottom to the top before we even started. This proof almost wrote itself. All right. So for the parallel ones, that's what you will do, those four steps. All right. I need to show you this. This works better in a classroom than it does on a slideshow on Zoom. But here's what the demo would be in class. I take a stick and I put it on the top of someone's desk. So if you can imagine that little brown square right there or brown parallelogram is a desktop. that stick PO, right, would be a stick that I'm putting on someone's desk, and I'm forming a right angle on their desk. So in other words, I'm forming this angle right here, this right angle right here. And what this basically says that if you form a right angle with any line XA on this desk, then it would also be perpendicular to any line that you draw through O. So for instance, this line as well would also form a right angle. It just certainly doesn't look like a right angle. It looks like an acute angle because it's drawn in two dimensions. And that's what this is trying to illustrate to you. That if you're perpendicular to any one of those lines, you're perpendicular to all of them as long as they go through point O. So that's what this says. It says a line and a plane are perpendicular if and only if they intersect, and the line is perpendicular to all the other coplanar lines that pass through O, except it doesn't say that. It says pass through the intersection point. Lastly, pointing out the fact that in our book, if a shape is color to it, then they're trying to tell you it's in three dimensions as well too. Okay. All right, so let's do this proof right here. So it's colored, it's from our book, so therefore it's in three dimensions. If you can kind of imagine this, it looks like a paper airplane, and the paper airplane is sitting on a desk. The desk is X or plane X, and that paper airplane is a combination of those two triangles. We are trying to prove that PA is congruent to PB. So PA and PB are parts of two different triangles. Therefore, show the two triangles are congruent, claim CPCTC. All right, so let's see if we can do this. Well, I'm going to go to the initial statement. I know how it's going to end. It's going to end with a CPCTC. I'm going to show that those two triangles are congruent. All right, back to my given. Well, I have AO and BO are congruent. So AO and BO are the bottom, and I have PO is perpendicular to the plane. If PO is perpendicular to the plane, there's my AO, BO. If PO is perpendicular to the plane, then by the previous demonstration, then we know that it forms two right angles, right? So that means that angle AOP and BOP are both 90 degrees. And if they're both 90 degrees, well, then they must be congruent to one another, right? Because they're literally equal to the same number. You screaming at the screen right now? Hopefully you are, because look what's left on the triangles. Ooh, we got another reflexive property. That reflexive property just pops up all the time. All right, now read the triangles. Left triangle says SAS. The right triangle says SAS. So therefore, we're done with the proof because we already knew how it was going to end. It was going to end with CPCTC. This is flavor number one. Okay, so two big ideas today. To show that two sides or two angles are congruent, show they're part of two different triangles, prove the two triangles are congruent, and then claim the magic word CPCTC. And big idea number two, to show that two sides are parallel, it's going to feel the same, slightly different. Show they're part of two different triangles, prove the triangles are congruent. Now claim CPCTC specifically for two alternate interior angles. And then if alternate interior angles are congruent, then the two sides are parallel. That's how you do every single proof tonight for homework. And that is where we end the class. All right, generally speaking, kids panic a little bit on this one. This one is the more challenging one because there's a lot of proofs. Tomorrow will be, our next class will be the same thing as well too. But I know you guys can do it. You simply just need to do a bunch of these for it to lock in. As always, if you have any questions, see me in the hallway or send me an email, and I will see you in the next class.